Hello everyone, welcome back. So in the last class, we were discussing about module 3, that is IC engine, refrigeration and air conditioning. So in the last class, we have discussed some basic concepts related to refrigeration and air conditioning. So we have discussed the refrigeration system, refrigerator, then refrigerant, and also we have discussed the parts of refrigerator. Okay, here we have mainly 4 parts of refrigerator: compressor, condenser, expansion valve, and evaporator. Next, so there are 2 types of refrigerator: vapor compression refrigerator and vapor absorption refrigerator. So in the last class we have discussed the working of vapor compression refrigerator and vapor absorption refrigerator. And also we have discussed the difference between vapor compression and vapor absorption refrigerator. Now in this session, so we will discuss the refrigerant definition, desirable properties of a good refrigerant, then commonly used refrigerants, then some standard terms used in the refrigeration like refrigeration, refrigeration effect, turn-off refrigeration, ice making capacity, coefficient of performance and relative coefficient of performance. Now let us discuss one by one. So refrigerant, so what do you mean by refrigerant? So the working medium used in the refrigerator is called as refrigerant. The working medium used in the refrigerator or the working fluid used in the refrigerator is called as refrigerant. Okay, here many fluids are available, but I cannot able to use all fluids so as a refrigerant. So in order to become a refrigerant, okay, here they should possess some desirable properties to produce effective cooling. So in order to produce effective cooling, refrigerant should have some desirable properties like physical properties, chemical properties, thermodynamic properties. So when a refrigerant satisfies some desirable properties, then we can use those fluids as a refrigerants. Okay, when a refrigerant satisfies some desirable properties, so okay, here say example thermodynamic properties, then physical properties and chemical properties. When a refrigerant satisfies some desirable properties, then we can use such fluids as a refrigerants. Now let us discuss one by one. Thermodynamic properties. First one, a good refrigerant should have low freezing temperature, so that it should not freeze at very lower temperature. A good refrigerant should have low freezing temperature, so that the refrigerant will not freeze at very lower temperature, and at the same time a good refrigerant should have low boiling temperature also. Low freezing temperature and low boiling temperature. Then high latent heat of vaporization. So when a refrigerant has high latent heat of vaporization, then it produces high refrigeration effect, means high cooling effect. Then high coefficient of performance. A good refrigerant should have high coefficient of performance, so that the energy spent in the refrigeration will be less. So that the energy spent in refrigeration will be very less. So these are all some thermodynamic properties like low freezing temperature, low boiling temperature, then high latent heat of vaporization and high coefficient of performance. So the next one, physical properties like low viscosity. What do you mean by viscosity? Viscosity is nothing but resistance to flow. A good refrigerant should have low viscosity both in liquid state and gaseous state, so that we can easily circulate the refrigerant throughout the system. So with a less pumping pressure, that's why a good refrigerant should have low viscosity, and a good refrigerant should have low specific heat also. A good refrigerant should have low specific heat. Then a good refrigerant should have low specific volume. So when a refrigerant has a low specific volume, then the size of compressor get reduced. So that, okay, here a good refrigerant should have low specific volume, so that the size of compressor get reduced. Then a good refrigerant should have high thermal conductivity, so that heat transfer takes place easily. Heat transfer takes place easily to the surrounding. A good refrigerant should have high thermal conductivity. So these are all about some few physical properties like low viscosity, low specific heat, then low specific volume and high thermal conductivity. Then a good refrigerant should have non-corrosive to prevent the corrosion of metallic parts of refrigerator. A good refrigerant should be non-corrosive. So in order to prevent the corrosion of metallic parts, okay, here we are using some metallic parts in refrigerator. So in order to prevent the corrosion, a good refrigerant should be non-toxic. At the same time, non-explosive also. Okay, it should not explosive. Okay, it should not explode. Okay, here good refrigerant should be non-explosive and non-toxic also. So a good refrigerant, okay, it should be non-toxic. Then non-flammable. Non-flammable means it should not catch fire easily. It should not catch fire easily. And a good refrigerant should be chemically stable. It should not decompose. It should not decompose. It should be chemically stable. So these are all some few chemical properties. Okay, next one we will discuss commonly used refrigerants. The commonly used refrigerants are ammonia, carbon dioxide, sulfur dioxide, methyl chloride, Freon 12 and Freon 22. So the first one, ammonia. Ammonia refrigerant, chemical formula NH3. Ammonia refrigerant, it is mainly used in vapor absorption refrigeration system. Then so it is also used in ice manufacturing plants. Ammonia refrigerant, it is also used in ice manufacturing plants. Next, ammonia refrigerant, so it is not used in domestic refrigeration system. So because of its toxic in nature, and hence ammonia refrigerant, it is mainly used in vapor absorption refrigeration system and in manufacturing of ice. Next one, the second one, carbon dioxide. So the carbon dioxide CO2, so it is used in marine refrigerator. So why carbon dioxide used in marine refrigerator? Because carbon dioxide, it has low specific volume. So because of its low specific volume, the compressor size is small, and hence carbon dioxide, it is suitable for marine refrigerator. The next one, sulfur dioxide, SO2. It was used in domestic refrigerator earlier. So it was used in domestic refrigerator, but nowadays sulfur dioxide is not at all used because of its toxic in nature. And similarly, methyl chloride. So methyl chloride also, it was used in domestic refrigerator system. So nowadays, Freon 12. So Freon 12 refrigerator, so it is used in the domestic refrigerator. So the chemical formula. Here we have two chlorines, dichloro-difluoromethane. Dichloro-difluoromethane. So this Freon 12, so it is commonly used in domestic refrigerators. So next one, Freon 22, the chemical formula, monochloro, here we have only one chlorine, monochloro-difluoromethane. Chemical formula, monochloro-difluoromethane. So it is used in air conditioner systems. It is used in air conditioners. So these are all the different types of refrigerants, are commonly used refrigerants. So ammonia, carbon dioxide, sulfur dioxide, methyl chloride, Freon 12 and Freon 22. Okay, here Freon 12 refrigerant is used in the domestic refrigerator. So the chemical formula, dichloro-difluoromethane. Freon 22, chemical formula, monochloro-difluoromethane. So it is used in air conditioners. So whereas Freon 12, it is used in domestic refrigerators. So why carbon dioxide suitable for marine refrigerator? Because of its low specific volume. So these are all the commonly used refrigerants. Okay, next we will discuss some standard definitions used in refrigeration. The first one, refrigeration effect, ton of refrigeration, ice making capacity, coefficient of performance and relative COP. The first term, refrigeration, so already we have discussed. So what do you mean by refrigeration? So refrigeration, it is a process of reducing the temperature of a system below that of surrounding temperature and maintaining that lower temperature by continuously removing the heat from the system. So consider a system, or consider refrigerated space where I need to reduce the temperature of system. So if you maintain the temperature of system below that of surrounding temperature, then that process is called as refrigeration, and you should maintain that lower temperature. You should maintain that lower temperature. So, how do we maintain that lower temperature? By continuously removing the heat from the system. So, this process is called as refrigeration, reducing the temperature of a system or a refrigerated space below that of surrounding temperature. That is called as refrigeration. Then refrigeration effect. Refrigeration effect means the rate at which heat removed by refrigerator from the refrigerated system, from the refrigerated space. Say example, okay, here. So, this is the refrigerator. So, refrigerator R1, consider 2 refrigerator. So, this is refrigerator R2. This refrigerator removes heat, so 150 joule per minute. This refrigerator removes, so 500 joule heat per minute. Now, which refrigerator has more cooling effect? Means which refrigerator produces more cooling effect? So, the R2 refrigerator produces more cooling effect because it removes more amount of heat, So, refrigeration effect means heat removed by the refrigerator divided by time taken. So, therefore, refrigeration effect, it is defined as the rate at which, rate means time, rate at which heat removed by the refrigerator from the refrigerated space, it is called as refrigeration effect. So, it is also called as capacity of refrigerator. Higher the capacity means higher the cooling effect. Higher the cooling effect means it removes more amount of heat from the refrigerated space. So, higher the refrigeration effect means the refrigerator produces more cooling effect. So, the unit kilojoule per second. So, as per this definition, heat removed divided by time taken, or kilojoule per minute, or kilowatt. So, refrigeration effect, it is also called as capacity of refrigerator. Higher the capacity means higher the cooling effect. So, refrigeration effect means heat removed by the refrigerator divided by time taken. The next one, ton of refrigeration. So, ton of refrigeration, so it is used as a unit of refrigeration. It is used as unit of refrigeration. So, the ton of refrigeration, it is defined as heat removed from water in order to produce 1 ton of ice in 24 hours when the initial temperature of water is at 0 degrees centigrade. See, in order to produce ice, we need to remove heat from the water. So, ton of refrigeration is defined as amount of heat removed from the water. Amount of heat removed from the water in order to produce 1 ton of ice in 24 hours when the initial temperature of water is at 0 degrees centigrade. So, in SI unit, 1 ton of refrigeration, which is equal to 210 kilojoule per minute or 3.5 kilowatt. So, next, ice making capacity. Ice making capacity is defined as the ability or a capacity of a refrigerator to make ice starting from water at room temperature. So, it is called as ice making capacity. So, it is specified by kg per hour or kg per minute, okay, amount of ice produced per hour. So, ability or a capacity, okay, of a refrigerator to make ice starting from water. So, it is specified by kg per hour. So, this is the definition of ice making capacity. So, next we will discuss the definition of coefficient of performance and relative coefficient of performance. Okay, the next definition, coefficient of performance. So, the performance of a refrigerator is measured by a factor called as coefficient of performance or simply COP. Okay, here this diagram shows a refrigerator system. So we know that the function of refrigerator system, this refrigerator removes the heat from the refrigerated space and rejects the heat to the surrounding atmosphere. So by taking external work, without this work refrigerator does not work. Therefore, refrigerator takes external work and removes heat from the refrigerated space or freezer. Now COP is defined as the ratio of heat removed to the work supplied. The ratio of heat removed to the work supplied. So it is called as coefficient of performance. So the higher the COP means the more efficient is the device. The more efficient is the device. So coefficient of performance is nothing but ratio of heat removed to the work supplied. The last definition, relative COP. Relative COP, it is defined as the ratio of actual COP divided by theoretical COP. It is the ratio of actual COP and theoretical COP. Actual COP is measured during the test and relative COP is obtained by applying laws of thermodynamics to the refrigeration cycle. Relative COP, so theoretical COP it is obtained by applying laws of thermodynamics to the refrigeration cycle, whereas actual COP is obtained during test. So these two ratios, so ratio of actual COP to the theoretical COP is called relative COP, whereas coefficient of performance, it is the ratio of heat removed, nothing but Q. So this is Q, heat removed to the work supplied, it is called as coefficient of performance. So these are all some standard definitions related to the refrigeration. So far we have discussed the refrigerant, desirable properties of refrigerants, commonly used refrigerants, then some standard definitions like refrigeration, refrigeration effect, ton of refrigeration, ice making capacity, coefficient of performance and relative COP. So the next topic, air conditioning. So what do you mean by air conditioning? So air conditioning means, so it is the simultaneous control of air temperature, humidity, air movement and cleanliness of air within an enclosed space. Within an enclosed space, so it is called as air conditioning. So air conditioning, it involves increasing the temperature or decreasing the temperature, or humidifying the air or dehumidifying the air, or controlling the movement, and controlling the movement of air and air filtering. So means air conditioning means it involves mainly four processes. So increasing or decreasing the temperature as per our requirement, humidification or dehumidification, air movement and air filtering. Okay, assume that we are in summer season. In the summer season, obviously the temperature is very high. So around 35 degrees centigrade to 40 degrees centigrade, and also relative humidity is also very high. So about 70% of relative humidity, it is uncomfortable to human being. The comfortable temperature for human being is 26 degree, and also the relative humidity is about 55%. So this is the comfortable condition. So therefore in case of summer season, we need to reduce the temperature of air, and also we need to dehumidify the air, means we need to remove water particle present in the air in case of summer season. In case of winter season, the temperature is obviously about 5 degrees centigrade to 10 degrees centigrade, and the relative humidity about 40%. Okay, here. So these two conditions are very uncomfortable to human being. To get the comfortable environment, we need to increase the temperature during winter season, and also we should humidify the air, means we should add water particles to the air. So in case of summer season, so we are going to reduce the temperature of air and dehumidification. Dehumidification means, so we are going to remove the water particles during summer season. In case of winter season, we are going to increase the temperature of air and humidification of air. So therefore air conditioning means it involves mainly four processes. The first one, increasing the temperature or decreasing the temperature as per our requirement. Second one, humidification or dehumidification. And third one, air movement, controlling the air movement, and last one, air filtering. Okay, we need to remove dust particles present in the air. Next, coming to classification of air conditioning. Air conditioning systems are classified according to the purpose. According to the purpose, let's say example, to get comfortable conditions. So comfortable air conditioning systems. Okay, these are all the comfortable air conditioning system applications. So industrial or process air conditioning systems. Okay, here these are all the industrial applications or process applications. Next, According to the season of the year, winter AC system, summer AC system and year-round AC system. In case of winter AC system, so air is heated and humidified. In case of summer season, air is cooled and dehumidified. According to the arrangement of equipments, we have unitary system, central station system and combination system. So usually central station systems are suitable for air conditioning of theatres, buildings, malls, hospitals. So these are all some classifications of air conditioning system according to the purpose, comfort AC system and industrial AC system. So according to the season of the year, winter, summer and year-round AC system. According to the arrangement of equipment, unitary, central and combination system. Now let us move on to the applications of air conditioning systems. So applications of air conditioning systems, okay, here we have comfort applications and process applications. So what are all the comfort applications? Okay, here, so air conditioning systems are used in cars, buses, trains, aircraft and ships to provide comfortable environment to the passengers. And also comfort air conditioning systems are used in following areas like houses, hospital, hotels, apartments, shopping centers, banks, malls, etc. So these are all the comfort applications of air conditioning. Then process application means, okay, here some few process require some optimum temperature. So at which, so the process can be executed. So say example ATM machine. Okay, here ATM machine, it works at a particular temperature. So therefore we need to provide a proper temperature, to that machine, and CNC machines also. So process applications involves, so okay, here chemical industry, textile industry, food processing industry, data processing industry, printing industries and ATM machines and CNC machines. So these are all process applications of air conditioning systems. So next we will discuss the working of window type air conditioning system and split air conditioning system. So how does a window type room air conditioner and split air conditioning system work? So let us discuss. Okay, next let us discuss the working of window type room air conditioner and working of split air room air conditioner. This diagram shows window type room air conditioner and this diagram shows split air room air conditioner. So the window type room air conditioner consists of compressor, condenser, expansion valve and evaporator coils. Okay, here the room side and outside are separated by a partition wall. So in order to install this kind of room air conditioner, so we require a square slot or rectangle slot, so in the wall of the room. So it consists of compressor, condenser, then expansion valve and evaporator coil. And here we have a common motor which runs condenser fan and blower. Okay, so next one, okay, here this is the outside of the room and this is the inside of the room. The inside of and outside of the room is separated by partition wall. Now let us discuss the working. So this is the room side where I need to cool the air, means I need to reduce the temperature of air. Okay, here we have an air filter. Now let us begin with compressor. So already we have discussed the working of vapor compression refrigeration system. So this window type room air conditioner consists of vapor compression refrigeration units. Now let us begin with compressor. So number one, compressor receives, okay, here this diagram shows the receiving side. So this arrow mark shows the receiving side. The compressor receives low pressure and low temperature vapor refrigerant, low pressure and low temperature vapor refrigerant from the evaporator. From the evaporator, low pressure and low temperature vapor refrigerant enters into the compressor. Compressor compresses the low pressure and low temperature vapor refrigerant so that, okay, here we'll get, this is the output, so we'll get high pressure and high temperature vapor refrigerant. Now the high pressure and high temperature vapor refrigerant enters into the condenser coil. Now this is the condenser fan. this condenser fan circulates the atmospheric air over the condenser coil, to convert vapor refrigerant into liquid refrigerant. So, to convert vapor refrigerant into liquid refrigerant. Therefore, in the condenser, so we will get the liquid refrigerant. Now, the liquid refrigerant enters into the expansion valve. In the expansion valve, expansion of liquid refrigerant takes place. Due to expansion, both pressure and temperature get reduced to lower value. Now, the low pressure and low temperature liquid refrigerant enters into the evaporator coils, or evaporator tubes. Now, the hot air from the room, it is sucked through the air filter. This air filter removes the dust present in the air. Now, the hot air is sucked through the air filter and it is made to flow over the evaporator tubes. Inside the evaporator tube, we have cold liquid, means cold refrigerant. That cold refrigerant absorbs the heat. So, okay, here, so this is the hot air from room flows over the evaporator tubes. Hot air from the room flows over the evaporator tubes. When the hot air flows over the evaporator tubes, that cold refrigerant inside the evaporator tube absorbs the heat from the hot air, so that the temperature of air get reduced, so that we will get cold air. And also, so the moisture present in the air, it is also removed. So, therefore, we will get cold air and also dehumidified air. Now, this conditioned air is sent back to the room. Next, in the evaporator, we have vapor refrigerant. So, because of heat absorption, the liquid refrigerant get converted into vapor refrigerant. Again, the vapor refrigerant enters into the compressor and the cycle repeats. This is the working of window type room air conditioner. So, in order to install this window type room air conditioner, so we require square slot or rectangle slot. Once again, I will go to explain the working principle. Okay, here, so we have compressor, condenser, expansion valve, evaporator. This is the air filter, and here we have a motor which runs fan and blower. Initially, the vapor refrigerant enters into the compressor. First point. So, compressor compresses the vapor refrigerant to high pressure and high temperature. Now, the high pressure and high temperature vapor refrigerant enters into the condenser. This condenser fan circulates the atmospheric air over the condenser coil, so that in the condenser we will get the liquid refrigerant. This liquid refrigerant now enters into the expansion valve. In the expansion valve, expansion of liquid refrigerant takes place. So, due to expansion, pressure and temperature get reduced to lower value. Now, the low pressure and low temperature liquid refrigerant enters into the evaporator tube. Now, in the evaporator tube, we have low pressure and low temperature liquid refrigerant. Now, the hot air from the room, it is sucked through the air filter and it is made to flow over the tube. When the hot air flows over the tube, the liquid refrigerant in the evaporator absorbs the heat from the hot air, and also air is dehumidified. When the air is cooled, so it rejects its moisture. Now, the conditioned air, means the cold air and dehumidified air, again sent back to the room. So, this is the working principle of window type room air conditioner. Now, let us discuss the working principle of split air room air conditioner. So, nowadays split air conditioner popular compared to window type air conditioner system. So, the working principle is same as that of split air, so window type air conditioner, and components are also same. Components are also same. Now, okay, here this split air conditioner, okay, here it consists of two units. So, outside unit and inside unit. This entire portion is inside unit and this is the outside unit. Outside unit consists of compressor and condenser unit. Inside unit consists of evaporator and expansion valve. Evaporator and expansion valve. Next one. Okay, here we have a condenser fan. Now let us discuss the working principle. Okay, here in order to fix this split air conditioner, we do not require a slot in the wall of the room. Okay, here the outside unit and inside units are connected by small diameter tubes. Therefore, it does not require any slot in the room of the wall. But here, in case of window type room air conditioner, we require a slot in the wall of the room, but here it requires only small holes in order to connect outside unit and inside unit. Now let us discuss the working principle beginning with compressor, same as that of window type room air conditioner, beginning with compressor. So compressor receives vapor refrigerant from the evaporator and compresses to high pressure and high temperature. Now the high pressure and high temperature vapor refrigerant enters into the condenser. This condenser fan circulates the atmospheric air so over the condenser coil. So this fan circulates the atmospheric air over the condenser coil to convert vapor refrigerant into liquid refrigerant. Now the liquid refrigerant from the condenser enters into the expansion valve. In the expansion valve, expansion of liquid refrigerant takes place. Due to expansion, pressure and temperature get reduced to lower value. Now the low pressure and low temperature liquid refrigerant enters into the evaporator. Now in the evaporator we have cold refrigerant. Now hot air from the room, it is sucked through the air filter and it is made to flow over the evaporator tube. When the hot air flows over the evaporator tube, the cold refrigerant inside the evaporator tube absorbs the heat from the air, and also air is dehumidified, means moisture content is removed. So next up, the conditioned air. So once the temperature of air is get reduced, okay, here the conditioned air again it is sent back to the room. Now in the evaporator we have vapor form of refrigerant because of heat absorption, liquid form converted into vapor form. Now the vapor form enters into the compressor and the cycle repeats. So this is the working principle of split air conditioner. Now let us discuss the difference between window type room air conditioner and split air room air conditioner. So window type room air conditioner consists of single unit. Okay, here it consists of single unit. All components, compressor, condenser, expansion valve and evaporator coils are kept in a single box. Whereas split air conditioner, it consists of two units. So outside unit and inside unit. So outside unit and inside units are connected by small diametrical tubes. Next one. So window type room air conditioner. So in order to install this kind of air conditioner, so we require a slot in the wall of the room. But in order to install split air conditioner, just here we need small hole in the wall of the room. So we do not require any slot. In the wall of the room. So that is the major advantages of split air conditioner. And window type room air conditioner, so less costlier, and split air room conditioners are, so compared to window type room air conditioner, costlier. And here window type room air conditioners, they have less cooling efficiency and they have high cooling efficiency. And it produces more noise and it produces less noise. And window type room air conditioners are suitable for cooling small sized rooms, whereas split air conditioners are suitable for cooling large sized rooms, offices and commercials. So these are all the difference between window type room air conditioner and split air room air conditioners. Thank you.